All right, our learning target for today, we're starting our new unit, and this is our final unit before the semester is over. It's a lot of material, and we only have just a couple weeks to get it all in. But it's percents, and we're going to start off with tape diagrams. It ends when you go on break, the winter break. What? Fantastic. Okay, so for here we have percents and tape diagrams is what our focus is going to be on. You guys should be somewhat familiar with tape diagrams. Tape diagrams was utilized quite often when they introduced fractions to you guys, when they started introducing the process of equations to you guys. Tape diagrams is a very common use, but we're going to go ahead and use it now with our representations of percentages. So on your paper, what we see here is we see a large bar that's representing a value of 80, and I'm going to go ahead and zoom in on that so you guys can see it a little bit easier up on the screen. We have a large bar that's representing 80, and then we have a series of smaller bars, and we've got this little portion right here that we're wanting to say is representing an unknown percentage, an unknown value for a percent. So now these little boxes are being split up like so. What I want you to do is off to the side, just somewhere on your paper, write down some things that you notice about the situation and something that you wonder about the situation. Take about a minute to write down what you observe, what you've noticed, or what you see is happening here, and what you are questioning about the picture. Okay, what is something that someone notices about the picture? Marshall?
The percent on the missing one is 60.
Okay, Marshall thinks that the percent on the missing one, the percent or the value of the bars? The value. So Marshall thinks the values of these bars is worth 60. Anybody agree or disagree? How many of you agree with him that these bars, if you put these three bars together, that would represent 60? Okay, how many of you disagree? Okay, how many of you have no idea? Okay, so we'll check in on that, and we'll see if Marshall's right or not. What's another observation or something that you've noticed? Isaiah? Okay, this bottom part is broken down into 4 parts. Now, there's 2 ways that we could observe it, right? We can observe it as 4 parts for a percentage, and we could observe it as 4 parts for a whole. We know the whole is 80. What's a whole for a percentage? What's a whole percent? 100, right? So that's something that we could make note of right here, is that this 80 represents 100%, doesn't it?
Yeah.
So if this 80 represents 100%, look at these little bars. From the start of the little bar to the back of the last one, is it the same measurement as this whole? Yeah. So that means that this whole thing here is also 100%. So how do you think we can figure out what each of these percentages would be? Aeon? Very good. I think that's a great idea. We could take 100 or we could take 80. Either one of those. So now if I take 100 and divide it by 4, that would tell me each of the percentages, wouldn't it? If I take 100%, so let's write that off to the side. If I take 100% and I divide that by 4, because I've got 4 boxes, that's going to represent what percentage each box is. What's 100 divided by 4? 25%. Good. So that means that each one of these boxes represents 25%. So I have 25% here. I've got another 25%. I've got another 25%. And even this one box that's not shaded is also 25%. So if I know that each of these is 25%, what percentage is the shaded box is going to be, Diana? 75%. So I know that this shaded box is 75%. I know this shaded box is 75% because if I add 25, 25, and 25, I'm going to get my 75% for here. Now, let's talk about what each box represents as a whole, no longer as a percentage. So we know the whole here is 80. So how do I figure out what each box is going to be? Adonai?
Divide 80 by 4.
Very good. So now we're going to take 80 and we're going to divide it by 4. And what's 80 divided by 4, guys?
20.
20. So that means that each one of these boxes, each one of these individual boxes is going to be worth 20, 20, 20, and 20. So if I wanted to know what the shaded region was, what is the shaded region? Brian? Just this shaded region, not the whole shaded region. We know the whole is 80. What is this small portion, Josiah? 60. So was Marshall correct?
Yes.
Yeah. Marshall's observation was correct. He said that this shaded portion would represent 60. So very good. Yeah.
What I did is I did 80 divided by 4 and then 20 times 3.
There you go. So because same thing we did right here, right? 80 divided by 4, which gave us 20, and then if we multiply that by the 3 boxes that are shaded, that would give you the 60. So we know that this representation is 60. So what this means, we found that 75% represents the same thing as 60 out of 100. So let's write that observation down. 75% of, and we'll do this one in blue. This is blue. 75% of 80. Actually, you know what? I'm going to change my colors. I'm so sorry. But I want to make sure that I can get it to relate back to what we're going to do later. So scratch that for a second. We're not going to use that color. And we're going to pretend that this was green. We're going to say that 75%, that's in blue, of 80, which is our whole was 80, is 60. That's our statement. 75% of the 80 is going to equal 60. That's how tape diagrams work. Tape diagrams work in the sense that they take a large portion, they can break it up into small sections, and then you can find portions of that percent, or you can even find percentages greater than the whole. So we're going to look at a couple of examples like that in a moment as well. Let's take a look at this problem we have here. Jada has a puppy that weighs 9 pounds. This, so this that they're referring to is what? When they're saying this, what information are they referring to? The puppy, right? The puppy's weight. So when we're saying the word this, we're referring to the 9 pounds. Those 9 pounds that the puppy weighs is only 20% of its full-grown adult weight. Does that mean the puppy's going to get bigger?
Yes.
Yeah, right? 20% is only a portion of what the full-grown adult weight is going to be. What percentage do you think is going to represent a full-grown adult? 100%. Once you are fully grown, 100% is going to represent your adult weight, the puppy or the dog's adult weight. Okay? So 9 pounds is going to be 20% of the full-grown adult weight. So here we've got a tape diagram to represent that. Notice that my first box is my shaded box. That's 9 pounds. That represents the puppy, and it's 20%. How do you think that I knew to go ahead and put 4 more boxes here? How did I know to go ahead and put 4 more boxes at the end of this? Isaiah? Five times the 20 will equal what? 100. 5 times 20. So if I know that each box is going to be 20%, I got to have 5 of them, because 20% times 5 is going to equal 100. So each of these percentages, each of these boxes here, they're representing 20%. Each of these boxes is going to represent 20%. That means that this box is 20%. This box is 20%. This one is 20%. This one is 20%. And if I add all that together, I get a total of 100%. So now, each box doesn't just represent a percentage, it also represents the pound or the weight of the dog. The dog right now is 9 pounds. But then we're going to add another 9 pounds and another 9 pounds and another 9 pounds and another 9 pounds to get a total weight of how many pounds? 45 pounds. So 45 pounds, this represents the adult. This is going to represent the adult's information. Marshall? Oh, of course, you're definitely going to use calculators for this unit. Okay, so based off of what we just wrote here is how we know the adult weight is going to be 45 pounds. We can see that from the diagram because we were able to create, the first thing we did is we created 100% by multiplication, right? That's what Isaiah said. He says he multiplied. He knows that if he takes 20 and multiplies it by 5, he's going to get 100%. So we did 100% by multiplying 20% times 5. Because we could do 20% times 5, that means we could also take 9 pounds and multiply it by 5. So therefore, we can do 9 pounds times 5, and that equals the 45. So these tape diagrams are going to help us to be able to see what is projected for a full 100%, what are portions of that 100%, or what might be more than 100%. So let's take a look here at problem 2. Jada's friend has a dog that weighs 90 pounds. So her dog, the bigger dog is 90 pounds. We've got a tape diagram that Jada drew to represent the weight of her friend's dog and the weight of Jada's puppy. Okay, so we're going to go ahead and label those right now. We've got Jada's puppy at the bottom. And we've got the friend's dog up at the top. Tissues are over there. Okay. We've got Jada's puppy and we've got our friend's dog. Notice that Jada's puppy, since it was a size of just 9 pounds, I went ahead and broke up the friend's dog in increments of 9. But there's 90 pounds, right? So how many boxes does that mean I had to have? 10, right? If we took 90 and we divided it by 9, that means we have 10 equal boxes of 9 pounds each. So since there's 10 boxes, what percentage does each of these boxes equal? No, that's 9 pounds. What percent? So I was able to do 90 divided by 9 to equal the 10 boxes, right? 90 divided by 9 equals those 10 boxes. So each of these boxes, though, is going to equal what percent? Remember, a whole percentage is 100%, and we've got 10 boxes. What is each percentage going to be, Angel? 10%. So each of these boxes is worth just 10%. Because again, I'm going to put off to the side here. If I take 100% and divide it by the 10 boxes that I created, that's going to equal 10%. So each one of these boxes is just worth 10%. I want to make sure I fill all that out for you. Okay, now again, like I said, Jada's puppy is only 9 pounds. So here's the value that represents Jada's little puppy. So how many times greater is the dog's weight than the puppy's weight? Marshall? 10 times greater. Okay? The dog, because we were able to make 10 equal-sized boxes for one size of the puppy, it's 10 times greater. So now what we're going to do is we're going to create a fraction that compares the puppy's weight to the dog's weight. Okay? So if I create a fraction, how many boxes represents Jada's puppy? No, how many boxes? 1 box represents Jada's puppy, right? The puppy is just going to be 1 box. How many boxes is going to represent the dog? How many boxes is the dog? 10. Okay, 10 boxes represents the dog. So if we are creating a fraction comparing the puppy to the dog, that fraction is just going to be 1 over 10. If we were to create a percentage then, a percentage that represents the puppy in comparison to the dog, what percent is the puppy? 10%, right? The puppy is just 10%. Only 1 box can fill in for the puppy. That's 10%. It's pretty simple stuff, right? Okay. All right, so for here, going on to our next page, it says Noah has $5. So the first thing that we're going to want to do is we want to create a tape diagram to represent the amount of money that Noah has. So we're going to have to figure out how we want to split his $5 up. So there's a couple of different ways that we could actually split that $5 up. We could split it up as single dollar increments. If I do single dollar for each box, then how many boxes would I need? 5, right? I would need 5 boxes. So I'm going to draw 5 boxes up at the top here. Yes. Nope. Okay, so I've got 5 boxes, and each box here would represent $1. So I'm going to write $1 inside. I could also split it up as 50 cents instead. If I split it up as 50 cents, how many boxes would I need to represent $5? 10. I would need to represent $5. If I split it up as 50 cents, I would need 10 boxes. So I'm going to go ahead and do 10 boxes this way. Okay, so each of these would just represent 50 cents. So I'd just put 0.50 inside of each of them. And I would have 10 of them because, again, 10 of these would represent $5. You do 50 cents times 10, you're going to get $5. Make sure you're not walking around my room. Okay, so these are just 2 different ways that we could split up the same amount of money. We can split it up as dollars, or we can split it up as 50 cents. Now, depending on the situation, one diagram might be more beneficial than the other diagram. So let's take a look at what they're representing. Okay. Elena has 40% as much money as Noah, 40%. So that means I need to figure out what each of these boxes represents as a percentage. So if I'm starting with this first box up here, again, 100% is the full size of it. How many boxes did we have up here? 5. So if I divided this by 5, then what does each of these boxes represent? What percent would each of these boxes? 20, right? We would have 20% for each of these boxes here. Now, with this bottom problem, that's a little bit different, isn't it? For the bottom problem, how many boxes did we have? 10. So if I took 100% and then divided it by 10, how much would each of these be represented? 10%. So each of these would be 10%. So we want to make sure that we understand the percentage for each of the boxes depending on which tape diagram we would have gone with. So everybody might go with a different one as long as you've got the same representation. So now again, it says that Elena has 40% of the money that Noah has. Elena's amount is just 40%. So let's go with this first diagram. How many boxes would I need to highlight in order to represent 40%? Brian? 2. So if I highlight 2 boxes, that represents 40%. How much money is that? How much money did I highlight? $2, right? $2. Now let's say I use the bottom diagram. It should still come out the same way. With the bottom diagram, how many boxes would I need to highlight in order to represent 40%? 4. I would need 4 boxes. So 1, 2, 3, 4 boxes. So if I do 50 cents plus 50 cents plus 50 cents plus 50 cents, that also comes out to $2. So this means that Elena has got $2, which represents 40% of Noah's $5. So 40%, that 40% is going to be $2 for Elena. Elena's got $2 when Noah's got $5. Everybody understand that so far? Okay. So now we're going to compare Elena's and Noah's money using fractions. Using a fraction, we're going to make that comparison. So how much did Elena have? She had $2. How much did Noah have? $5. So it was 2 over 5. If we look at this diagram, it was 2 boxes highlighted out of 5 boxes total. If we look at this diagram, it's 4 boxes out of 10, but 4 over 10 simplifies to 2 over 5. So 2/5. Okay, let's take a look at problem 4. For problem 4, we're no longer focusing on Elena, we're now focusing on Diego. Diego has 150% as much as Noah. 150%. So his is going to be a larger portion. I'm going to go ahead and highlight Diego's amount in orange. Diego's got 150%. Okay, so that means I need to be able to identify 100% and another 50%. That's how I'm going to break it up. I'm going to break it up into 100% plus another 50%. That's going to equal the 150%. What's 100% of Noah's money? $5, right? Let's take a look at that first diagram, that first top diagram. If I do 100%, if I highlight the whole thing, that whole thing is 100%, isn't it? That entire thing is 100%. So 100% is going to be $5. Plus, we need to do another 50%. Can I use this first diagram to represent 50%? No, because it's all in increments of 20s, isn't it? It's 20%, 20%, 20%. I don't have 50%. Can I use this diagram to represent 50%?
Yes.
Yeah. How many boxes would be 50%? 5 boxes. 50%. Each percentage is 10%. 5 boxes would represent 50%. So 5 boxes, how much money is that? We don't say $2.5, we say $2.50. So $2.50. So 100% plus 50% is 150%. What's $5 plus $2.50? $7.50. Okay, so Diego would have $7.50. $7.50 in comparison to Noah. Okay? Any questions? All right, we're going to go ahead and we're just going to skip problem B because I want to get on to some of the other stuff. So we'll go ahead and skip problem B. All right, let's take a look now at these problems. For problem number 5, we've got tape diagram to represent Priya's distance that she's walking and a tape diagram to represent Tyler's distance that he's walking. Depending on how you want to compare, if you're comparing Priya to Tyler, it's different than if you compare Tyler to Priya because they walked different amounts. So when you are comparing them, if I'm wanting to know what percent of Priya's distance did Tyler walk, then I need to take Priya's boxes and figure out what each of those percentages is worth. So each box for Priya is worth blank percent because 100% divided by blank is going to equal blank, right? So we want to fill this information in first. So we need to first figure out how many parts is Priya's diagram split up into? 5. Priya's parts is split up into 5. She has 5 boxes. So I know I'm going to take 100% and I'm going to divide it by 5. What's 100 divided by 5? 20, right? 100 divided by 5 is 20. So that means that each of these boxes is worth 20%. Each of these boxes is worth 20%. So for Priya, this is 20%. The second one is also another 20%. Then another 20%. And so on and so forth. Each of these boxes is worth 20%. So now the question is what percent of Priya's distance did Tyler walk? So Tyler, this is Tyler's distance. We want to relate that back to Priya's distance, which is 20, 40, 60, 80. That means that Tyler walked 80% of Priya's distance. Tyler was able to walk 80% of Priya's distance. But if I change the question up, let's say instead now I want to focus on Tyler's boxes. I just want to focus on Tyler's boxes. How many boxes was Tyler's distance? 4. Tyler's distance was 4 boxes. So I'm going to take 100%. I'm going to divide it by 4. And what's 100 divided by 4? 25. Okay, thank you for raising your hand, Natalia. 25. So that means that each of these boxes is 25%. Because again, it depends on which way are you looking at it. If you're comparing Priya to Tyler, or are you comparing Tyler to Priya? Okay, so Tyler as a whole is 25% for each box. So now, if I'm wanting to look at Priya, Priya's got 1, 2, 3, 4, and an additional 1. So what percent is Priya compared to Tyler? 125. Very good. Because we know that Priya is going to cover all of all of Tyler, 1, 2, 3, 4, but then she's going to have an extra one right here, so that's an extra 25% that she's going to have. If we calculate all that together, that comes out to 125%. So Priya walked 125% of Tyler's distance. All right, go ahead and go on to the next page. All right, so what we're going to do here for these ones, we're going to do one of these together, and you're going to do the second one on your own. You're going to want to answer each of these questions before you start building your tape diagram, so that way it kind of helps you. It helps to model what you're going to be doing. So the first thing that we're going to do, inside the question, I want to know what percent do we see. So inside of this problem, who can tell me what percent do they see? Reading through the question, what percentage do you see? Anasia? 25%. We see a percentage right here, 25%. So I now need to know what fraction is that out of 100%. So if I put 25 over 100, what does that simplify to? 25 over 100 is what?
5 over 10.
Not 5 over 10.
1 over 4.
1 over 4. Very good. It's 1 over 4. Why are you laughing? You didn't even try. It's 1 over 4. Okay, so that means, because it's 1 out of 4, that means that we're going to have to create 4 sections. Whatever my denominator is going to tell me how many sections I need to create, or how many boxes I need to create. So off to the side, I'm going to create a a tape diagram, and I'm going to split it up into 4 equal-sized boxes. And I also know my percentage already. I know that each of these boxes is worth 25%. So now I need to figure out what goes inside of the boxes, not the percentage, but the amount of gasoline, or the gallons of gasoline that it can hold. So we want to know how many gallons will each section of the tape diagram hold. So based off of that, we now need to look at what the car held. The car held 16 gallons, right? So we're also going to take that whole, and we're going to divide it by the 4 sections. And how many gallons is each section going to be worth? Tally? 4. 4 gallons is going to be what each section is worth. So I'm going to put 4, and I'll put GAL for gallons, and then 4 gallons, 4 gallons, and another 4 gallons. So each of these boxes is worth 4 gallons. Now it says that the truck can hold 25% more. The truck can hold 25% more. So that means what we're going to do is we're going to take the amount that the car can hold, which is 100% of the car, and then we're going to add it with 25% more. So we're going to take the car's 25%, and we're going to add that on. So 100% of the car's amount was 16 gallons. Plus, what's 25% of the car's amount? 4, right? 25% is just a 4. 4 gallons. So the truck is able to hold 20 gallons. Which makes sense. If I were to go ahead and add an additional 25%, they can hold 25% more for the truck. That means I'd add another 4 gallons on. If I do 4 times the 5, I'd get 20. So the important thing is for you to understand, are you doing more than that tape diagram, or are you doing less than the tape diagram? You want to make sure you're checking to see if you're going to be adding to your tape diagram or removing from your tape diagram. Go ahead and do the next problem on your own. Okay, so let's go ahead and go over this. The percentage that we see in the problem is 20%. Notice that it says 20% fewer, so that means instead of adding on to our diagram, we're going to take away from our diagram eventually. But we do see 20 is our percentage. We also know that 20 out of 100 can simplify to 1 over 5, so that means that we're going to need 5 sections. When I create my tape diagram, I'm going to need to make a diagram that is worth 5 sections. So I'm going to draw my diagram, and I'm going to split it up into 1, 2, 3, 4, 5. I've got 5 boxes that I'm going to split it up into. And then I need to go ahead and take the other number that I see, which is my old car was 15 gallons. My old car was 15 gallons. I'm going to take that 15, I'm going to divide it by the 5 sections, and that's going to equal 3 gallons for my old car. So each one of these we know was worth 20%. Each one of these was worth 20%. And then that each gallon was 3. Okay, this represents 100% of the old car right now. Our new car is 20% fewer. So to show that it's 20% fewer, all I need to do is get rid of one of the 20%, don't I? 20% fewer, if I cross off one of the percentage, how big is the new car's gallon size? 12. Right? That represents 20% fewer. I'm just going to remove 20% from my tape diagram, and I'm left with 12 gallons for my new one. Okay? All right, let's take a look at this next one. The tape diagram shows Sonara gave 70 haircuts this week. So the tape diagram, the whole is 70. The percentage is 100%. The whole percentage is 100%, right? So let's figure out first what each box is worth. So let's count how many boxes there are. How many boxes do we have here? Count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have 10 boxes, right? Okay, so each box is worth what percentage? 10%. Each box is worth 10%, so if you label it out like that, it makes it easier. And then how many haircuts is each box worth? 10, right? If we do 100% divided by 10, we get 10%. If we do 70 divided by 10, we get what? 7. So each of these is worth 7 haircuts, isn't it? Okay, so each of those is worth 7 haircuts. So now, 70 haircuts. What percentage, Dayana, shut up. What percentage is 70 haircuts worth? What percent is 70 haircuts worth? 100%. 70 haircuts is 100%. What percentage is 7 haircuts worth? 10%. Good. So now, what percentage would 63 haircuts be worth? How much? 90, right? If we do 7, that's 14, 21, 28, 35, 42, 49, 54, 63. Okay? So this portion right here, I'm going to highlight it in green. This portion right here is going to be 63. That means that this portion right here is 90%. I want you guys to flip it on over. Do the last two problems on your own. Do the last two problems on your own. All right, let's go over this one. So for here, we have banjos, 0 to 15, and their percentage is 0 to 100%. That means 15 represents what percentage? What does 15? 15 represents 100%. So 15 banjos, and here we would write 100%. Now they want to know, what does 3 banjos represent? So if we're going down to 3, we're splitting the 15 up by 5s. By sections of 5. So if I do, this is 3, this is 6, this is 9, this is 12, and oh, sorry, it's not very well spaced, and there's 15. So then if I divide this by 5, then that means this would be 20%, this would be 40%, this would be 60%, this would be 80%. So 3 banjos represents 20. And 6 banjos represents what? 40%. 6 banjos represents 40%. Okay, you're just breaking them up based off of the little increments that they have. Okay, let's take a look at the next one. The tape diagram shows that Elizabeth spent 91 minutes, which was 70%. So is 91 minutes the whole? No. Okay, 91 minutes is only a portion. It's only 70%. Okay, so first thing that I want to do is I want to figure out, what does each of these boxes represent? So I'm going to take 91. I'm going to divide it by how many boxes? How many boxes are highlighted here? 7. So I'm going to divide that by 7. 91 divided by 7 represents what? Shh. 91 divided by 7, what is that? 13. So each of these boxes is 13. Each of these boxes is 13. Shh. That means each of these additional boxes would also be worth 13. And then we would have the whole percentage is 100%. Okay, so what we want to do is, we know that 70% is how much? 70% is how much? 91. So now what is 10%? 13. 10% is just 13, right? Each of these boxes is worth 10%. What's 100%? What's 100% going to be? So do 13 times 10 boxes. What is 100%? 130. Okay? If you get onto Google Classroom, you have your assignment is loaded in there. It's the IXL skill. Get logged in. If you can get the IXL skill done in the next 7 minutes, it's a quick skill. If you can get it done in 7 minutes, you'll get the additional pride point.